Welcome back to the Hardware Unboxed News Corner. Normally this week would be one of those weeks after a big GPU launch, except that this week's release, the NVIDIA GeForce RTX 2080 Super, was a bit of a fizzer. Really don't blame you guys for not being super interested in that product because we weren't either. We're definitely more curious to see where AMD goes with future Navi GPUs and what is in store with NVIDIA's next generation. I think we can put the whole Super launch behind us. Aside from that, there have been some interesting stories pop up, so, well, let's get into it. First up, I want to talk about Intel's TDP metric and their turbo clock ratings. AnandTech this week published a fascinating interview with Intel fellow Guy Therian, hopefully I pronounced that name right, who is the chief architect of Intel's client performance segmentation. The interview goes through a range of topics, but I found the discussion on TDP some of the most interesting stuff. According to Therian, Intel's official definition of the TDP is as follows. TDP is an average power dissipation at a maximum junction temperature operating condition limit specified in Intel's engineering datasheet for that processor, for which the processor is validated during manufacturing and when executing an associated Intel-specified high-complexity workload at that frequency. So at face value, not the most straightforward explanation, but he goes on to explain that the TDP is really a metric for customers to know that they are getting a certain level of performance in a worst case environment within the TDP. That level of performance is the base frequency. In other words, Intel guarantees that if you design a cooler and power delivery system to handle the rated TDP of the processor, it will operate no lower than the base frequency in a high complexity workload. Intel's TDP is also an average power dissipation metric. This is how boost algorithms come into play. Essentially, if the CPU is idling for some period of time, it's building up a power budget that it can spend on a high-performance workload when required. As soon as that workload is active, it can spike up to boost clocks and consume power above the TDP, and then when the power budget is used up, it falls back to running within the TDP. The algorithm ensures that when averaged over the idle period, boost period, and base period, the average power dissipation remains within the TDP, and that's basically how it's validated. The time period over which the average is calculated can be controlled by OEMs and is called tau. This is where a lot of the discussion between TDP limited and TDP unlimited performance comes from. On a TDP limited system, say you have the 9900K and you're enforcing the 95 watt limit, that tau value could be short, and this is how a lot of systems with weaker coolers or power systems come configured. The performance on this system is lower because you get a short period of boost and a longer period where the CPU operates at the TDP to keep within that overall average power metric. But for high performance systems, say you buy a high-end motherboard that's designed to be used with a good cooling solution, the motherboard maker sees no reason to cap the tau limit because the power delivery and cooler should be good enough to run at the boost clocks for an extended period of time. So the tau value is effectively unlimited on these products and we get unlimited performance. Well, I guess unlimited in the sense that instead of capping to the TDP, performance is capped by the maximum turbo clocks for the CPU. Crucially, Intel says that TDP unlimited performance is still within spec. It's not overclocking. Intel allows OEMs and customers to adjust the power limits and tau limits of their CPUs to fit with their cooling and power delivery capabilities. All the TDP ensures is that a customer building a system with a certain CPU can hit base clocks with the absolute minimal cooler and power system to handle the TDP in worst case scenarios. This does mean that Intel CPUs will perform differently depending on the cooler power system and configuration by the motherboard OEM. Here at Hardware Unboxed, we basically exclusively test with these CPUs unlimited because we figure most enthusiasts will be pairing something like a 9900K with a good cooler and a high-end motherboard, but that might not be representative of the performance you'd get from a crappy pre-built. And honestly, how this works with Intel is very similar to with AMD. AMD's 3rd gen Ryzen CPUs, for example, basically run as fast as they possibly can, provided you have a good enough cooler and power system. But rather than giving the control to motherboard vendors as to whether they should go flat out or keep within a certain limit, with Precision Boost 2, that basically happens automatically. I find all this stuff super interesting, and there's a lot of other really interesting tidbits in the interview. We have the source link for the AnandTech interview in the description below. It's well worth a read. of all the other stuff covered if you're an enthusiast interested in technical details. In other news, Corsair has acquired pre-built PC maker Origin PC. The US company has been in the market for a long time and has a well-established brand offering high-end, customized boutique PCs for gamers and other applications. Corsair have also dabbled in a few high-end pre-builts like their Corsair One series, so the acquisition will strengthen this department. Corsair and Origin are both private companies, so there are no details on how much this cost Corsair. However, Origin will remain a separate brand within Corsair and will continue to operate from its existing offices. Similarly, Corsair will continue to offer their own pre-builts, so this sounds very much like the Elgato acquisition where the company basically just operates as a division within Corsair. However, you would expect from this point on that Origin PCs will come with a lot of Corsair gear inside. Given just how many product categories Corsair covers, it does kind of make sense. TSMC have confirmed that development on their 3nm node, otherwise called N3, is well underway. As part of their 2019 second quarter results, CEO of TSMC, C.C. Wei, stated that on N3, the technology development process is going well and we are already engaging with the early customers on the technology definition. It's interesting to hear that TSMC are already talking with customers about 3nm. However, still early days. TSMC has only recently launched 7nm. They've got 7nm enhancements on the way, plus 5nm to get to before 3nm. So naturally, there hasn't been any discussion on the improvements 3nm will bring compared to those nodes. What we do know though is that 3nm is not just a refinement of 5nm. It is a brand new node, and we should see more on 3nm in a few years. Apple has acquired Intel's modem division for $1 billion US. As you'd expect for this sort of deal, Apple has bought intellectual property and equipment and will also acquire about 2,200 Intel employees. The deal is expected to close at the end of the year, pending all the usual regulatory stuff. It's an interesting turn of events for Apple and Intel in the modem industry. Earlier this year, Apple and Qualcomm settled their lengthy legal fight over wireless tech, and then shortly after, Intel announced that they were exiting the 5G smartphone modem business. Now, they've sold their modem division to Apple, so Apple will have the tools to compete directly with Qualcomm and develop their own IP instead of having to use Qualcomm, which is definitely a company they clearly hate. Despite this acquisition, Intel will still retain the rights to develop modems for non-smartphone applications such as PCs, Internet of Things devices, and autonomous vehicles. CEO Bob Swan said that this agreement enables us to focus on developing technology for the 5G network while retaining critical intellectual property and modem technology that our team has created. It'll also be interesting to see whether Apple uses Intel's fabs for their homemade modems. You think that would be the case. A couple of weeks ago, we talked about MSI's upcoming Max motherboards, which bring larger BIOS chips to AM4 motherboards with 300 and 400 series chipsets. Well, those boards are now available. There are 2 X470 boards, 7 B450 models, and an A320 board in the lineup. All offer out-of-the-box support for Ryzen 3000 series models and have maximum compatibility for AM4 CPUs without needing to mess around with different BIOS revisions. A number of the boards also support higher frequency memory up to DDR4 4133, although we still recommend most users stick to DDR4 3600 due to 3rd gen Ryzen's design. PCIe 4.0 isn't supported though, as expected. That's still exclusive to X570. According to market analyst firm Gartner, DRAM prices are set for a steep drop throughout the rest of 2019. Demand-driven oversupply could lead to as much as a 42.1% drop in DRAM prices. Gotta love the precision there, 42.1% exactly, and that should be happening at some point in 2019. With a large amount of excess stock, these prices may remain until midway through 2020 as that stock gets sold through. Memory prices have already dropped significantly since their ludicrously high points just a little while ago. In fact, for a number of popular DDR4 kits, pricing has halved since the super bad days. But DDR4 is also a relatively old technology these days, and DDR5 is on the horizon, so we should be seeing prices come down naturally over the course of its lifespan, and it seems this could happen across the rest of 2019. Wolfenstein Youngblood is now available on PC and it has launched without RTX capabilities. The game is one of the latest titles that is supposed to support ray tracing on Nvidia's Turing GPUs, but as reported in VentureBeat, RTX will be added in a later patch. Apparently the developers are still working with Nvidia to get it looking as good as possible, although no date was specified for when RTX would be introduced. Youngblood is the first Vulkan title to integrate RTX support, and it could also be a great showcase for the technology, given the id 6 engine can run at hundreds of FPS even at higher resolutions. If ray tracing isn't a super drastic hit to performance, it could be the first game where playing with ray tracing on doesn't impact performance enough to hurt the experience. We'll see what that situation is like when the patch launches eventually. And finally, we have the Acer Nitro VG240YP. As reported by TFT Central, this is a 23.8-inch 1080p 144Hz IPS panel, which is exciting because high refresh 1080p IPS displays have been quite rare up until recently. In fact, this type of display is one of the most frequently requested, and it seems panel manufacturers have finally gotten around to offering it. No word on pricing or release date yet, but we'll keep an eye out on it. That's it for this week's News Corner. As always, you can subscribe to catch this segment every week or thereabouts. Consider supporting us on Patreon, because in the next few days we will have our exclusive monthly live stream with Steve and myself, and I'll catch you in the next one.